but vector is literally just going to kind of look like a ray. So it's just like a little arrow, and when you write this, the vector has what we call a magnitude and a direction. Okay, it has what we call a magnitude and a direction, and I'm going to give you guys the definition of the magnitude just real quick to the side in a second. But whenever you have a vector, you start on a graph. I just spelled the word from wrong. Okay, you start from 0, 0, and we're going to draw one in just a second. I promise it's not hard. If you can plot a point, you can draw a vector. But they always start from 0, 0, so right at the origin when you graph these. And then the direction is going to be like a compass direction, like north or south or something like that. We'll do that in a second. The magnitude, though, is literally just the length of the arrow that we'll draw in the coordinate plane. It's just the length of the arrow, and all we're going to use to find it is the Pythagorean theorem. Just the a squared plus b squared equals c squared. We can just use that to find a magnitude if we have a picture of a vector, if we have coordinates. All right, so literally all we're going to do in this first question, we're just going to draw a vector. Whenever you have a vector, this is how they write it. It sort of looks like a coordinate point, but instead of having parentheses, it has these little symbols. That's how you indicate that it's a vector. It kind of looks like a greater than and a less than symbol, but that's just to indicate you're working with a vector. All you have to do, find that point on the graph. So I'm just going to go over 5 down 3. And whenever you draw a vector, you're going to start it at the origin. And I'm just going to literally just draw an arrow that points to that 5, negative 3. That's all you have to do. So if you can plot that point, just connect it from the origin with a little arrow pointing to the point. That's your vector. Okay, now, easiest way, if you guys remember from like the first part of geometry, they have a distance formula. We could find the length of that segment. I promise you, the distance formula and the Pythagorean theorem are basically the same thing, but I think it's a little bit easier, especially if you have a graph. Just do yourself like a little Pythagorean theorem. So I'm just going to, just real quick, I'm going to kind of turn this into a little right triangle. Just kind of drawing the legs there. The vector will always be the hypotenuse if you're drawing a triangle. And it's possible to have a vertical or a horizontal vector. In that case, bless you, you can literally just count if it's on the x-axis or y-axis. You can just count the length. But if it's a diagonal like this, I'll just do like a little tiny Pythagorean theorem. So this leg, I went over 5 and I went down 3. But in terms of that being a length, I went down 3, but that would have a distance of 3. And we just do the Pythagorean theorem. So the legs will always be what I just drew in, and the vector, the magnitude of the vector will always be the hypotenuse because it's going to be across from the right angle. So I'm just going to do 5 squared plus 3 squared equals my magnitude squared. And we're just going to round these to the nearest tenth. So on your calculator, we'll just grab this out. I'm going to do 5 squared plus 3 squared, and that's going to give us 34. That's equal to my magnitude squared. If I just want my magnitude, just m by itself, what would you have to do there? Square root. That's all I got to do. Guys, let's put the computers away. You do not need those right now. That's okay. That's okay. You just just go grab one of mine back there. I gotcha. So just the nearest tenth. So that's just one decimal place. So what would you guys round that to? What, like 5 point? 5 point what?
9.
Why 9?
3, yeah.
Okay, yeah, it's really tricky. So anything after the 8, right? It's 4 or below, you're going to round down. If it's 5 or above, you round up. So this would just be 5.8 for your magnitude. All right. Is anybody having a question? Now, the direction of the vector, and we're going to do this in this example down here in just a second, but do you guys know, and I'll label this on these diagrams as we go. So if you have a coordinate plane, I could also kind of turn it into a compass. So like north, south, this would be west, and this would be east. And we can label that, and some of these diagrams might have that labeled, but the direction of the vector is literally going to be compass directions. And to get these, if we don't have the angle, we might need to use like a little bit of trig to find the angle, but on the first set of questions here, we're just going to have the angle given to us. All right, now this is a little, go ahead.
How are we determining, like, for Z, is that, like, west-west, or is it just like west, or?
That's what we're going to talk about. It's a little bit weird, so I'm going to try to explain it to you here. All right, so you have, I'm just going to label like a little compass on this first example. So you guys can see, here's my vector, right? And the angle is coming from the x-axis and going up. All right, now this is a little bit weird how you would describe this. So you start from either the x-axis or the y-axis, wherever the vector's at. In this case, to form that angle, I'm starting with the x-axis. Okay, so I am moving, I'm starting on the east side and I'm going up. So the way you would describe this is 62 degrees north of east. So I'm going up here, wherever you're starting the angle, and then you move toward the vector. So if I'm going up, it's north. If I'm going down, it's south. We'll do another example on a different axis here in a second, but I'm going north of that east side of the compass, and so that's how we describe it, north of east. If you want to just write like N of E, it's not northeast, it's north of east. Go ahead.
Could you say it was just like 28 east of north?
Yes, you can say that too. Very good. There's two different ways to describe each of these vectors. I was just going with what they had in the picture. Okay, how'd you get the 28?
91, 62.
Right, okay, so whenever you have in the quadrant system here, in the coordinate plane, like right in the corner, that would be 90 degrees. So I could also do this angle, and you could do, I don't want you guys to write this because I don't want you to get confused, but if you wanted to go through and find this angle measure, you don't have to do this. This would be a 28 degree angle here. So another way I could describe this same vector, you could call it 28 degrees. Now in that case, let me draw a different angle here. That goes from the north and you go towards the east. So the way you would describe that would be east of north. But you don't have to go through and do that. If you want to just use the angle that's in the diagram, you can, but there are two ways to describe each of these.
I know, like, I've noticed all of these angles, when interpreted like, directly without like taking the other side of the angle, follow the conventional order, like northeast, yeah, or like northwest.
We don't. That's the description. It's like east of north or north of east. The description. They don't use northwest. They do that for some other stuff when you get into bearings and things like that, but we don't do that for the vectors. But good point. Good point. Yeah. Yeah. You guys will do that when you get to trig too. So for this one. Okay. Let me see if you guys. So one side will be either the x-axis or the y-axis of that graph. And you want to describe, like, where are you starting and how are you moving to get to the vector. So I'd say right here, does anyone want to try this one? This is 34 degrees. Can anybody raise your hand and tell me how you would, like, what of what? What do you think?
34 degrees west of, no, north of west.
Perfect. Perfect. So I'm just going to write north of west. Because you're starting on the west side, you're going up, so it's north of west. All right, now, let me draw on this one here. So the 71 degree angle here, and you don't have to label these, but I'm just putting those compass directions to help if anybody forgets. How would you describe this last picture? It's 71 degrees. Like, where are you starting and which direction are you going to get to the vector? West of south. You're starting on the south side and you're moving towards this way, so it's west of south. And if you want to write the word out, you can, or if you want to abbreviate, either way is fine with me. Is anybody having a question? Yeah. Oh, I gotcha. What we're going to do in example 3 here is we're just going to try to sketch a vector. Now, you don't need to get a protractor out or measure this. We're just going to kind of eyeball. So think about right directly in the middle of the quadrant. If you went right from the origin, right in the center, that would be 45 degrees. So this one says 40 degrees east of north. Whatever the second word is, that's where you're going to start. So let me label this real quick. So we got north, south, west. Sorry, I should have labeled these ahead of time. Okay, so whatever second, you're going to start on that side and you're going to go towards the first word. So east of north, I'm going to start on the north side and go towards the east. And again, it doesn't have to be perfect. 45 degrees would be a direct diagonal. So I'm just going to kind of try to do just like a little bit less than that. It doesn't have to be perfect. And then I'm just going to ask you to put the angle measure in between where you start and where you get to your vector. So this is 40 degrees east of north, and just kind of eyeball where you think 40 degrees would be. 45 is directly in the middle. So if I do this one, so I've got north, south, west, and east. Now, whatever the second word is, that's the side you would start on. So I'd start on the east, and it says south of east, so I would go down towards the south. Now, this is going to be, remember, 45 is like directly in the middle, so I'm going to make it a little bit bigger than that. That's probably not perfect, but as long as you put the angle between those two, so this is saying I'm going 60 degrees south of the east side of that graph, and so this would be the angle to get to the vector here. So you're just going to put the angle measure in between the vector and the side of the compass there. So this one says, you guys try this one. I'll just be quiet and you try to do it on your paper. So this is 30 degrees north of west. And just eyeball the angle. It doesn't have to be perfect. And then see if it kind of matches up with mine. Start on the second word, bless you. And if it says go north, go up. If it says south, go down. If you start on the north and it says east, you go to the right. If it says west, you go to the left. Is anybody having a question about sketching that? Is this making sense to you guys? Okay, cool. All right, now, on the back, I'm going to have you guys find the magnitude, which is just the length again, and the direction of the vector. And it just says at the top, if we're going to find an angle, just round to the nearest degree. If we're going to find a length, we're going to round to the nearest tenth like we've been doing. So first thing we're going to do, we're just going to draw this vector. So it says -6, 7. So we're going to find that point. So I'm going to go over 6 and up 7. It'll be way, way at the top of the graph. Whenever you draw a vector, you just start at the origin and literally just draw an arrow that points to that point they gave you. Okay, now to do the magnitude, if you want, I'm just gonna, I always connect these to the x-axis if I can. You can connect it to the y-axis, but when you guys get to trig, that'll make a little bit more sense why I'm doing that, but it's always a good idea to just connect it to the x-axis to make your little triangle. And you can actually use the numbers from the point there. So I went 6 to the left. That has a distance of 6. We're not using -6 there. And then I'm going up 7, distance of 7. The magnitude is just the length of that arrow. So it's always the hypotenuse because it's across from the right angle. So I think we got to grab our calculators here because I don't think this is a nice number. So in any order, the 6 squared and the 7 squared going to equal your magnitude squared. So let's see what that is. So if I, whoops, delete both of those. Let's see, this is 85. And then all you got to do, remember to cancel out the square. It would not make sense for that arrow to have a length of 85. Don't forget that. Like if it's 6 and 7, 85 would be way too big to be that third side. So don't forget to take the square root, because sometimes people will forget to do that. And I'm just going to go 1 decimal place after the decimal sign. So I'm going to 9 point, then I have a 2, 1. So what would you would round this to 9 point what? 2. Perfect. Perfect. So that's your magnitude. That's just the length of the arrow. That's all that is. And then we're going to talk about how to find the direction. And the direction is going to be based on some trig. All right, so there's 2 ways you can do this. I'm just going to do it based on the triangle that I have in there. So I'm going to say my angle, I'm just going to put a little theta. And on this graph, the way I'm going to find that is going to take me from, if this is the west side, this is the north, this is going to be north of west, how I'm going to describe this angle here. All right, now, let's see what you guys might remember from last week. I'm just going to kind of sketch this to the side so you can see it. Here's my theta. This is 7. This is 6. You could use x if you don't like the theta. How is the 7 related to that angle? Like opposite, adjacent, or hypotenuse? Because this is a right triangle.
Opposite.
Perfect. Okay, what about the 6? Okay, so do you guys remember sine, cosine, or tangent? Yes, good, good, good. I think that got erased off the board. I need to put that back up. All right, so I'm going to do tangent of theta. Remember, if you don't know the angle measure, we're just going to have to do one step here. The opposite would be the 7. The adjacent would be the 6 to set up that ratio. All right, how do I cancel out the tangent? Do you guys remember? Yes, yes, yes. All right, so you're just going to hit second on your calculator before you hit the tangent button. So I'm just going to do second tan, and then inverse tangent is what that is. And then we're going to round this to the nearest degree. So what do you guys think? What nearest whole number would you round that to?
40.
Perfect. All right. Now, if I look back, okay, so I've got part of my answer. I have the angle measure, but you have to also describe the direction it's going. So, like, you know, north of west, how would you describe where this angle's at in the coordinate plane there? 49 degrees.
North of west.
Perfect. North of west. Awesome. Is anybody having a question? Okay, I'm going to slide this up just a little bit. Now, what we call the components of a vector, that is literally just what I have in the question above here where we had the -6, 7. The components of the vector are just the coordinates, just kind of like an x comma y. It's just written in that format with that little bit different notation instead of a parenthesis. That is the component of your vector, and it's just the x and y coordinates where the vector points. That's all it is. That's the components of your vector. Okay, so we're going to find the components here. So they give us a little bit different information in this lovely little picture. They actually give us the magnitude. Like I can see that right in the drawing, that 120 is labeling the length of the vector. And what would you guys tell me for the direction here? I've got 42 degrees. How would you describe that one?
Southeast.
South of east. Perfect. Okay, so I've got the magnitude and direction. What I don't know is where is this arrow pointing? So again, I'm just going to turn this into a little right triangle, and I promise you, please just do this for me. Just connect the tip of the arrow to the x-axis. You can connect it to the y-axis, but I really want you to connect it to the x-axis because it will make so many problems that you do in future math classes easier. So just take the tip of the vector wherever it's at and just either draw straight up or straight down to the x-axis, the west-east axis, and make a little triangle here. Okay, now here's the deal. To get to this point, I would go over this distance, which would actually be the x-coordinate of the point, and I would go down this distance, which would just be the y-coordinate of the point. And if you always connect it to the x-axis, I'll show you this in a second, but you will always use the same like sine, cosine, or tangent for x and the same sine, cosine, or tangent to find y, but we're going to use trig to do this. So let me come to the side here really quick, and you don't need to redraw this because you can see it on your paper here. I'm just going to draw this with one variable. Just with one variable, so it's not so much in one diagram. So let's just say I wanted to find the x-coordinate of the point first, just so we can focus on that. So I have a 42-degree angle. How's the 120 related to that? The hypotenuse. The magnitude is always the hypotenuse, so if you have that magnitude, you automatically have the hypotenuse. Now, how is x related to that angle? Adjacent. It's attached to it. Okay, now I promise you. What is this, sine, cosine, or tangent? Cosine. If you attach your vector to the x-axis, you will always use the cosine, always use the cosine to find x. So you're just going to do cosine 42 equals the adjacent, which is, that's what we're trying to find, that's the x, over the hypotenuse, which is the 120. Okay, now I'm just going to draw a separate triangle real quick, and we'll actually find that in a second. So if I draw that same little thing, I'm just trying to draw it without information I don't need. I had a 42-degree angle, the magnitude was 120. The other thing we have to find is the y-coordinate to get my component. So if I do that, and I redraw that real quick, this is still the hypotenuse, because the magnitude's always the hypotenuse. How is y related to that angle?
Opposite.
Exactly. All right, so opposite hypotenuse would be? Yes. All right, so we're just going to do sine 42, and it's almost an identical setup. We're just going to use the other one. You will always use sine for y, and you will always use cosine for x if you attach your vector to the x-axis. If you just remember to do it, it'll make it so much easier. Okay, so I'm going to do two of these at once, but I'm not going to write my answer. I'm just going to show you something first. So let's do both of these. We just multiply by 120. So I'm going to do 120 times the cosine of the angle, which is 42. So this one, I'm just going to do one decimal place, like 89.2. Now, for the y, it's this almost identical, but it's 120 times the sine of 42. And so y here is 80.3. All right, now, you have everything you need to write your components, but I got to show you something before we do that. When you use the trig, we're assuming that we're working with a triangle, which we were working with a triangle, right? So these numbers are never going to be negative when we actually use the trig to find them. However, where this is placed in the coordinate plane, you might have one of those numbers needing to be negative based on where it's at. So I just want to write these real quick. If you're up in the first quadrant, both the x and the y are positive, right? If you're in this quadrant, you had to go left, so your x value is negative, and you had to go up, so your y value is positive. If you're in this is the third quadrant, you had to go left and you had to go down. So both the x and the y are negative in that quadrant. And then where we're at is the fourth quadrant. And to get to this point, my x value, I'm going to the right, so that would be positive. But the y value, we got to go down to get to that arrow, so that would be negative. So for this particular problem, you just have to remember where the vector is at and think about, like, do I need to add a negative sign? So in this quadrant, you use these 2 points. This is your x, this is your y. You just have to put a negative in front of the y. That's literally it. So you got the 89.2 comma negative, because you got to go down to get to where that vector's at. So negative 80.3. So just got to be mindful of that if you're writing the components. You do all the trig totally right, but just think about what quadrant your vector's in and think about what I might need to add in terms of a positive or negative. Okay, now I have one more problem. This one's probably the trickiest of all because it doesn't have any kind of a picture, so we're going to try and draw a picture here. So this says a helicopter lands at a point 200 miles west and 120 miles south of the point from which it took off. So let's just do it real quick. Let's just draw like an XY axis here. And I'm going to write north, south, west, and east just so we can label it right away. All right, now here is telling me I'm going to go 200 miles west. So I'm just going to start at the origin, and I'm just going to eyeball this. We don't have this labeled or anything, but I'm going to go 200 miles west. So let's say this is 200, this direction. Now, I'm going to go back to the origin. It says 200 miles west and 120 miles south. So, bless you. 100. I'm just eyeballing this, just not as far. Let's say this is 120. All right, so the actual point, though, like 200 west and 120 south, the actual point would be like out here. So I'm going to draw my little vector pointing to that point. And just like the other ones real quick here, I'm going to connect this to the x-axis in case we have to find any distances here. Now, if you look at that, I put that 200 in a really bad spot. I know that I did just now as I'm looking at this. What you're doing, you're going over this distance would be the 200. And forgive where I was trying to label my axis. Where I did that little connection there, you're going down 120. So you actually have the components given to you. Where I'm at, if I go west, that 200 has to be negative to get me in that quadrant. And the 120, we're going down. So these are actually both negative. That's your components of your vector right then and there. And then it just says describe the magnitude and direction of the vector. So we don't have to do anything for the components. We can just pick that out from the information. To get the magnitude, remember the magnitude is just the hypotenuse. So we're just going to do a little Pythagorean theorem. So I'm just going to do 200 squared, 120 squared. That's my magnitude squared. And let me see what that is. All right, so I got 54,400. You guys don't have to write this down. You can just do it in your calculator. But I'm going to take square root of that. And we're just going to go to the nearest tenth. So I'm going to say like 233.2 for my magnitude. And then just so we can have a little bit better of a picture, let me draw this to the side here. To get your magnitude, we got that, and then to get my direction, I need to find this angle that I'm going from that west side to get to that vector. Now, I would use the numbers we have in the problem, so the 200 and the 120, and every time, this should be, if you're finding the direction, if you don't know the angle, every time it should be tangent, because this will be opposite, this will be adjacent. I don't want to use the magnitude only because I rounded it. And if you can use numbers that you got in the problem that are not rounded, that's better to do. So I'm just going to do, it'd be like tangent of theta is your opposite 120 over your adjacent, which is 200. You don't have to reduce that or anything like that. Just doing an inverse tangent to get the angle measure. So just on your calculator, just hit second tan, and then 120 over 200. Ooh, I'd round that up to, I got 30.96, so nearest degree I'd go up to 31. So my theta there, 31 degrees. How would you describe, so I got the angle measure, how would you describe the direction? So I'm going, here's south of west. You're going from the west side down, so it'd be south of west. Is anybody having a question? Okay, sweet. We have like 20 minutes left. So I'm going to let you guys work on the homework assignment. It should just be the next page in the lovely homework packet. And I'm going to go grab